Welcome. If you're studying for the AREs, you're in the right place. Today we're going to break down two of the most critical and honestly most confused concepts you'll see on the PPD and PDD exams, the air barrier and the airspace.
Okay, let's just dive right into this. It seems so simple on the surface, doesn't it? But believe me, getting this one wrong can cost you some serious points. So, are they the same thing? Not even close. Let's get this totally nailed down so you can walk into that exam feeling confident. So here's our game plan. We're going to start with why we even care about high-performance walls. Then, we'll define the air barrier as a shield and the airspace as a channel. After that, we'll tackle that super tricky insulation puzzle, and we'll finish up with a direct head-to-head comparison, basically your ultimate cheat sheet for the exams.
All right, first section, walls that work. Before we even get into barriers and spaces, you've got to understand the battlefield. A building's wall isn't just a divider, right? It's this high-performance system that's constantly fighting against the elements. Its whole job is to control the flow of air and water. You get that right, and you've got energy efficiency, durability, and happy clients.
Okay, on to our first key player, the air barrier. For the ARE, I want you to picture this thing as the building's ultimate unbroken shield. Its one and only job is to stop unwanted air from moving around. It's all about air tightness. Now, the official definition here has the biggest clue, and that's the word continuous. It's a continuous layer. Its purpose is to stop air from leaking in, that's infiltration, and to stop air from leaking out, that's exfiltration. Simple as that. Now, what's so cool about this is how this one single function does so many things. By stopping air, you stop energy loss. And by stopping that warm, moist indoor air from hitting a cold surface, you prevent condensation. This, of course, makes your heating and cooling systems way more efficient, and it protects the whole structure from moisture damage down the road. For the PPD exam, you have to remember it's about both energy and durability.
And this idea of being unbroken, it's completely non-negotiable. Continuity is everything. I mean, one tiny little gap, a seam that wasn't taped perfectly, a missed connection at a window, and the whole thing fails. If you can't trace that air barrier line in your wall detail without lifting your pen, it's not a functional air barrier, period.
So let's switch gears and see how different that is from the airspace. This thing plays a completely different, but just as important role in the wall. It's not a barrier at all, it's more like a pathway.
You see, unlike the barrier, which is an actual material, an airspace is defined by what's not there. It's an intentional, totally planned void. And this little gap is absolutely critical for high-performance walls.
And this slide just perfectly illustrates its main job, managing water. So when that hard, wind-driven rain gets past your siding, this space acts like a drainage channel. Gravity just pulls the water down and out. It also lets air circulate, which is huge for drying out any leftover moisture. This is the heart of a rain screen system, a huge topic for the PDD exam.
So the takeaway here is super simple. The air barrier has to be continuous, but the airspace, well, it's fundamentally a gap. It's a channel. It's designed to move water and air. Its whole job is just to be empty.
Okay, this brings us to a question that trips up so many people studying for the AREs. And because of that, you know the exam writers just love to throw it in there to test if you really get building science.
And the quick answer is a hard no. Definitely not. And really understanding the why behind that answer is what's going to separate you from the pack on the exam. It really all just depends on your wall assembly strategy. Let's just trace a really common high-performance wall from the outside in. Okay, so you've got your cladding, then that airspace for drainage. Behind that, your weather barrier. Now, look close at number 4, the sheathing, usually with taped seams, is acting as our air barrier. And what's crucial here? Notice it's on the exterior, or the cold side, of the insulation. This is a classic strategy in cold climates to stop warm, moist air from the inside from hitting a cold surface and creating condensation.
But like this slide shows, that's not the only way to do it. In systems that use continuous exterior insulation, you'll see this in super high-performance designs like Passive House. The insulation is completely outside the structure. So in that case, the air barrier can actually be behind the insulation, a lot of times right on the structural sheathing. And this is an amazing strategy because that continuous blanket of insulation keeps the whole structure warm, which basically kills thermal bridging.
Okay, let's bring this all home for the final showdown. This next slide, this is the one you want to screenshot, memorize it, be able to draw it from memory. This is the absolute core of what you need to know.
And here it is, the head-to-head. Let's run through it. Function: the air barrier seals. The airspace drains and vents. Easy enough. Purpose: the barrier is for energy savings and durability. The space is for moisture protection and drying. Location: the barrier is integrated into the envelope, while the space is that gap behind the cladding. And the biggest rule of all? Continuity. The air barrier must be continuous. The airspace is a gap. That is the #1 distinction you have to master.
You know what? Let's just boil this all down to the simplest possible formula for your exam. If you don't remember anything else, remember this. When you see a question on the PPD or PDD, your brain should immediately go, air barrier controls air. Airspace controls water. That's the mental shortcut that is going to guide you to the right answer every single time.
And that's our explainer. We've covered the what, the why, and the where. So as you keep studying, I want you to think about this final question. Climate matters. A lot. The physics are the same, but your strategy has to change. So how do these principles adapt? Keep digging into that, and seriously, good luck on your exams.